Okay, in this video I'm going to be working through a set of example problems on the derivatives of an inverse function, derivative of f inverse. Okay. So the first one is just, where they're going to give us, give it to us algebraically. Okay, the thing I think I need to say before I start in on this is to remind you of the formula, that the derivative of f inverse, that derivative is equal to 1 over f prime of f inverse, and I need to remind you that f inverse is actually an x value, right? Because f inverse takes in y values and brings you back x's. So for this first one, and I guess I will kind of label these with numbers. So for number one, if f is equal to 3x to the third minus x plus 4, what we're interested in is f inverse of 6, right? Because that's what we need to start with, start from the inside. So f inverse of 6, how we compute that is we say f of x equals 6. And that's where 3x to the third minus x plus 4 equals 6. And the thing I'll tell you about these is when they give it to you algebraically, almost always it's like a really obvious value of x. Because, you know, in general, like a third degree polynomial, if we can't factor it, we don't have much hope for solving it besides, you know, pulling out the cubic formula, and we don't want to do that. So what we're going to do instead is we're going to think, is there any obvious values? Okay, 0 doesn't work, but 1 does work, okay? And in order for the inverse function to make sense, it kind of needs to be a one-to-one function, so it's not like we have to worry about other ones. So I'm going to say this is x equals 1, because 3 minus 1 is 2, plus 4 is 6. Okay, let's be happy with that. And so it's going to be 1 over f prime of 1. Okay, well, f prime of x is going to be 9x to the 2 minus 1. Okay, so f prime of 1 is equal to 9 minus 1 is 8, meaning that f inverse prime of 6 is equal to 1 over 8. Okay, the next one is a table, and this is the much more common way to see this problem, right? Okay, so v equals g inverse of x. Okay, so v of 2, well, I guess what I'll do is I'll write out the formula. V prime of 2 is 1 over, well, it's g inverse prime of 2 is 1 over g prime of g inverse of 2. All right, g inverse of 2, I'm going to say g of x equals 2, and find out what x gave me that. Okay, g of x equals 2 right here, that's x equals 1. Okay, so I need 1 over g prime of 1, which is going to be 1 over, you go to the table and it's going to be right here, g prime of 1 is negative 2. Okay, the graph of y equals f of x is shown over here. I assume there's a question underneath here. Yeah. If g is the inverse function of f, the slope of the line tangent to the graph of g at x equals 5, well, that's f inverse prime of 5. That's going to be 1 over f prime of f inverse of 5. Okay. Now, well, hold on. I'm going to need to do some work first, because I need to figure out what is f inverse of 5. Okay, I'm going to set f of x equals 5. I'm going to go over here, and I'm going to say, okay, here's 5. I need to go, I found the spot, that's 4. So that's 1 over f prime of 4. I'm looking at the graph of f, and the slope here is looking like it rose 3 when it ran 2. So it's 1 over 3/2. It's going to be 2/3. All right, here's another one, algebraic. H prime of 1/12, or h inverse prime of 1/12. Okay, well, I need to say that's equal to 1 over h prime of h inverse of a 12th. In order to find h inverse of 1/12, I'm going to set h of x equals 1/12. That's going to happen when 1/12 of x minus 2 to the 3 power equals 1/12. So that's where x minus 2 to the 3 power equals 1. The only time that happens is where this thing is 1, so that means x needs to equal 3. So I'm probably also going to need h prime of x. Okay, so I'll just do that here. H prime of x is going to be 3/12 of x minus 2 to the second power times the derivative of x minus 2 for the chain rule, but that's just 1, so I'm done. And I'm going to say, well, h prime of 3 equals 1/4 of 1. So it's equal to 1/4, which is going to be 4. Slide that up a little bit. Just flip this over. Number 5. Table above gives selected values for a differentiable and increasing function f and its derivative. G is the inverse function of f. What's g prime of 3? Well, g prime of 3 is f inverse prime of 3. We've got a formula for that. That's 1/f prime of f inverse of 3. And we need to figure out what f inverse of 3 is. Set f of x equals 3. Go over here. I found it. There it is. Goes back to 1. X equals 1. So this is going to become 1/f prime of 1. F prime of 1 was 4, so that'll be 1. All right. 6. Okay, it's algebraically. F of x equals 2x plus e to the x. And they tell you f of 0 equals 1. Interesting. I mean, this is an invertible function. It's strictly increasing. So, I mean, you could take the inverse of this. I don't know that you would be able to. It might take some algebra trickery to write an explicit formula for the inverse function, but such a function does exist. Okay, so f of 0 is 1, meaning f inverse of 1 is going to equal 0, right? Yeah, definitely they want g prime of 1, so that's f inverse prime of 1. That's going to be 1/f prime of f inverse of 1. So that'll be f prime of 0. F prime of x is 2 plus e to the x, meaning f prime of 0 is going to be 2 plus 1 is 3. The last one, let's see, what do we got here? Oh, this is okay. This is the same as the table problem. It's just given to you, not in a table. Still gave you the data though. So I'm going to say I want g is f inverse g prime of 3. G prime of 3 is f inverse prime of 3, which is 1/f prime of f inverse. Okay, the question is, what is f inverse of 3? Looking for where f of x equals 3. Yeah, here it is. That's x equals 6. And then, what else do I want to say about this? Oh, I need to find the value of, okay, so that's going to be 1/f prime of 6. I need to find out what f prime of 6 is. Here it is, -2. And so that's 1/-2. And this is how you take the derivative of the inverse function for AP calculus.